You know, there's this incredible hidden force that's shaping literally everything from the stars way up in the sky to, well, the phone in your hand. Today, we're going to unlock the secrets of that force as we dive right into the heart of matter, nuclear physics.
So, let me ask you this. What's the one thing that powers a star, generates clean energy, and lets doctors see right inside the human body? It sounds like a riddle, right? But the answer is real, and it lies in the tiny, powerful heart of the atom, the nucleus. And honestly, understanding it is the key to unlocking our whole modern world. All right, first up, let's take a journey. We're going right inside the atom's heart, to the tiny, dense center of, well, everything.
So, what is nuclear physics when you boil it all down? It's the science that studies this nucleus. I mean, we're talking about a space that's almost unimaginably small and dense. But don't let the size fool you. It's where some of the most powerful interactions in the entire universe happen.
Okay, so inside that nucleus, you've got two main players on the team. First, you have the protons. They've got a positive charge. Then you have the neutrons, and, as the name kind of suggests, they're neutral, no charge at all. And get this, these two tiny particles, packed together, make up almost all the mass of an atom. Which brings us to a huge question. What holds this all together? Well, it turns out to be what you could call the universe's strongest glue. A force that, and I'm not exaggerating, literally holds our reality together.
Now just think about this for a second. If you've ever played with magnets, you know how the two positive ends push each other away, right? They repel each other. So, if you have all these positive protons crammed into one teeny tiny space, why doesn't the whole thing just fly apart? What stops it from just exploding?
The answer is a force with a great name, the strong nuclear force. And it's not just a clever name. It is, by far, the most powerful of the four fundamental forces of nature. We're talking stronger than gravity, stronger than electromagnetism. It's the champ. It acts like a cosmic superglue, holding that nucleus together against those insane repulsive forces.
Now, the energy tied up in this force, that's called binding energy. A great way to think about it is, it's the cost of keeping the peace inside that crowded, chaotic nucleus. And the amount of energy we're talking about here is just staggering. It's millions of times greater than the energy you get from a chemical reaction, like, say, burning gasoline. This energy right here is the key to some truly immense power.
So if there's that much energy locking things together, you have to wonder, right? What happens when we figure out how to unleash it? Well, let's dive into how we actually tap into the power of the atom.
It really comes down to two main paths to get that power. First, you've got fission. That's all about splitting a heavy nucleus apart. And then you've got fusion, which is the opposite. It's about mashing light nuclei together to make a heavier one. But here's the cool part. Whether you're splitting them apart or smashing them together, both processes release a truly tremendous amount of that binding energy.
But wait, there's actually a third path, one that happens all on its own in nature. See, some atomic nuclei are just, well, they're unstable. They can't quite hold it together forever. So over time, they naturally release energy in a process we all know as radioactive decay.
So when this decay happens, it releases energy in the form of radiation. And there are three main types you'll hear about: alpha radiation, beta radiation, and gamma radiation. Each one is a little different, and they all play a unique role in how this energy interacts with the world around us. Okay, so this isn't just some abstract stuff happening in a lab somewhere. Let's talk about how all of this actually shows up in our daily lives, and how it literally shapes the world we live in. So remember fission, the whole splitting atoms apart thing? Well, that is exactly how nuclear power plants work. They create a controlled chain reaction to generate a whole lot of heat, which boils water, creates steam, and spins turbines to generate electricity for millions and millions of people.
And what about radioactive decay? It's become an absolute cornerstone of modern medicine. It's the science that powers technologies like PET scans, which let doctors get an incredible look inside our bodies without ever making an incision. And it's the very same power behind radiation therapy that's used to fight diseases like cancer.
That same predictable, steady decay also works like a perfect cosmic clock. I'm talking about carbon dating. For archaeologists, the decay of an element called carbon-14 allows them to figure out the age of ancient bones and artifacts with just unbelievable precision. They are literally unlocking secrets from thousands of years in the past.
And now let's go from the ancient past to the grandest scale imaginable. Nuclear fusion, that process of combining atoms, is what makes the sun shine. It powers every single star you see in the night sky. These stars are giant fusion engines, and they're the cosmic forges that created all the heavier elements, the stuff that makes up planets and even you and me.
So, let's just pull back for a second and bring this all together. From the tiniest particles to the biggest stars in the sky, we've seen how nuclear physics is the engine powering our universe.
You know, there's a quote that just sums this up perfectly. From the heart of matter comes the energy that powers the universe, from the light of the sun to modern medical technology. And that really says it all, doesn't it? It shows just how connected everything really is.
So we've learned so much, right? We know how to harness the power of the nucleus for energy, for medicine, for looking back into our own history. But as we wrap this up, I want to leave you with a final thought. The nucleus has already completely transformed our world. The question is, what secrets does it still hold for our future?